I have the constructors project up from the last video and want to look again at the enum type. I didn't get too deep into them before because for the most part, you'll probably be using them in their simplest form. Usually, you'll just use an enum as a list of named constants, and sometimes you will find the ordinal values are important. I did show you how to include a method in the body of the enum and use that method in code as well, but I didn't cover constructors. How do constructors work on an enum? Let me set this up. First, I'll create a new Java class in the dev.lpa package, picking enum as the type and calling it generation. I'll add my constants. I'm going to set these up, one on each line. You'll understand why in just a moment. Each one of these represents a generational name, so a range of birth dates that describe if a person is in one of these groups. Hopefully you're somewhat familiar with these labels. I have Gen Z and Millennial, Gen X, then Baby Boomer, Silent Generation, and finally the Greatest Generation. Each of these represents a range of birth years. If you've got a young child, he or she is probably a Gen Z, and a grandparent might be a Baby Boomer or from the Silent Generation. Maybe you're a Millennial or a Gen X. Like any class, I can generate a constructor for an enum. I'll insert one after my constants list and before the class's closing brace. Notice after that's inserted that IntelliJ added a semicolon after the Greatest Generation constant. Anytime you add code to an enum other than the constants, you must include this semicolon. Okay, so first I'll just print a statement in this constructor. I'll have the code print out the value of this. Getting back to the main method, let's see what happens if I use this enum. I won't even use it. I'll just set up a local variable with that type to start. If I run that code, there's no evidence that the enum constructor was ever called. Next, I'll assign a value to that local variable, assigning it Baby Boomer. Running this code again. You can see the constructor didn't just run for the Baby Boomer, it ran for each one of the enum constants. When an enum is initialized, all its constants are initialized, which means the constructor was called for each and every constant. Now let's use the Java P tool to examine what an enum really is under the hood. I'll type in Java P, then -P, which means I want all members printed, including private and package private ones. I'll include the path where the class file is, and then just type generation, and then press enter. Running this, you can see that generation is a final class. I'll be covering final classes shortly. This class extends a special class in Java, a java.lang.enum. What's interesting here is you can see that each one of my constants is really a final static field that has the same type as this enum generation. Notice also that there's a constructor, it's private, near the bottom of this output. Let's see what else we can do here. It would be nice if I could include the corresponding year ranges associated with each enum constant. I could set up a method as I did in a previous example and return the result of a switch expression, which could be the year range, but I really want the range to be two fields, a start year and an end year. It turns out that I can add additional fields to an enum and use a constructor to populate them. As with most classes, I can add instance fields, so I'll add a start year and an end year. I'll insert these before my constructor, but after my constants list. I'm going to pass these as arguments to the constructor next. I'll assign the instance fields. This dot start year equals start year. This dot end year equals end year. I'll also print that year range out, concatenating the two variables to my println statement. Now look what these changes have done to my enum constant declarations. Every single one is showing an error. Because I created this explicit constructor, the implicit no-args one doesn't get created. This means I have to pass values to the constructor for each of these constants. How do I do that? I can achieve this by defining the arguments in parentheses after each constant name. I'll add 2001 and 2025 to Gen Z. These are the birth date range of years that get a person labelled as part of the Gen Z generation. I'll set Millennial to be 1981 to 2000. Gen X is 1965 to 1980. Baby Boomer is 1946 to 1964. The Silent Generation was born between 1927 and 1945. Finally, the Greatest Generation is 1901 to 1926. Now my code compiles and I can run it. You can see that each one got constructed and includes the year range. Let's run Java P again. I can just press the up arrow on that terminal session. This hasn't changed much, except it has the two instance fields, start year and end year. And there, on the third to last line, is the new signature for the constructor. You can see each parameter type is an int. It's also private, even though I didn't include an access modifier. In fact, let me add the public modifier to that constructor. That gives me an error, so I'll hover over that, and you can see the modifier public is not allowed here. Why not? Well, a constructor on an enum is implicitly private, whether we declare it that way or not. We can't declare a constructor here as either public or protected. I'll undo that last statement. The other thing that you should be aware of, now that you know these constructors are private, is that I can't actually create an instance of an enum. Let me go back to the main method. I'll set up another local variable and try to instantiate a new generation. IntelliJ tells me enum types can't be instantiated. What about an enum constant? I'll try to instantiate a new generation baby boomer, passing it a different range of values. And that too isn't permissible, so I'll just remove that last statement altogether. Getting back to the generation enum, I want those instance fields to be final. There won't be any need to change those values, so I'll add final to each of those declaration statements. I'll print that date range out in the toString method, so I'll generate that, selecting none for fields. I'll return this .name and the year range from this method. I'll also change that println statement in the constructor, just printing this alone again. Running this code, I get the same results. You can have more than one constructor in an enum. I'll generate another constructor, inserting this one before the existing constructor, and select none for the fields. Now I've got an explicit no args constructor. Like other classes, I can chain constructors, so I'll chain the toArgs constructor, passing 2001 and the current year, which I get using local date.now with getYear. For the GenZ constant, I can remove the arguments so that it'll execute the noargs constructor. I can define this with empty parentheses, or I can remove them altogether. Running this code, my GenZ end year is the current year. Now that you know that each constant is really a generation class, you can actually include a class body for each or any of these. I'll do this with GenZ, adding a class body, by including a starting and ending curly brace. Okay, so what happens if I just add a println statement there? I want this to print out special for GenZ, but this doesn't compile. If you thought about GenZ as a class, you'd realise that what I'm really doing here is inserting a line of code in a class body. I can't do that, but I can wrap it in another code block. I'll add another set of starting and ending curly braces. This compiles, and what do you think I'm doing here? Well, it's an instance initializer for the GenZ instance. Let's run this code now to see what it gives us. And here you can see that statement printed out. You can also declare methods in these constant class bodies. It's generally not a good idea to make your enum too complex though. If you need that much complexity, maybe a different approach would make more sense. Okay, so I think that covers constructors for records and enums. In the video after the next one, I want to talk a little more about final classes. You saw from the disassembled class that the generation enum is declared as a final class. This is also true of the person record. I'll be talking about that in that video, but first I want to give you a challenge to test what you've learned about these additional initialization techniques. See you in the next video.